Hey everybody, this is Robot here for Vespa Motorsport here in San Diego, scooterwest.com. It's a mail order operation. Today I'm going to talk about troubleshooting electrical charging problems and battery problems on any of the larger Vespas or Piaggio products. You got any of the Vespas that are pretty much 125 cc's on larger, they have a charging system that's referred to as a three-phase charging system. They got a flywheel that spins around with magnets on it, and then they have a series of coils that are in a triad that generate the alternating current electricity that goes through the regulator and the rectifier to charge the battery and power the rest of the scooter. I was going to talk about some of the problems I've seen over the years. For the most part, they're quite reliable, but there's some years that have some problems, and we'll go over those. So the most important tool you're going to need is just a regular multimeter. You don't necessarily need anything fancy, just a basic voltmeter that reads, you can set the 200 volts as an auto range one, real simple meter. You can find a meter that's about $9. It may not be the most accurate meter, but it'd be plenty accurate enough for doing the few tests that we're going to do on this scooter to show how the charging system's working. So first of all, you want to set it to DC voltage. The other one right up there is alternating current AC voltage. So DC voltage, you'll either see DC or that line with a dotted line under there. This is an auto ranging meter, so it automatically moves the decimal point. And I'm just going to manually set the range, but right now I think it's up to 20 volts, which is perfectly fine. Right now the scooter's off, and we could check the float voltage on a battery. Right here's a GTS 300. It'd be nearly identical on a 250, the GTV, any of the large frame Vespas, Primavera, Sprint. They have the battery under here. The battery's in there. Make sure your connections are tight. I think some of my past videos talking about the battery itself. That's a big problem. You just got weak or loose connections right there. We'll check the float voltage on this battery. And 12.56, that's about 60% charge. A fully charged battery, the float voltage would be about 12.8 volts. A weak battery would be anything 12 volts or lower. And I'll show you what the voltage does when we turn the ignition on. So 12.56, that's adequate. I don't know if there's glare in there a little bit, but I'm going to turn the ignition on. It drops a little bit, and that's pretty normal. You're going to see a big drop when we start the scooter. It's kind of a lot of noise. This charging system's working just perfect. It's coming right up to 14.2. You don't want to see the voltage ever really exceed 14.6. I'll give it a couple low revs. But the charging system on this 300 is working perfectly. If the battery's pretty weak, you may see a charging voltage of like 13.5, 13.8. That could be still normal. But with the battery that's in good condition, you should see, I would say, anywhere from 13.8 all the way to 14.6. If it's any higher, the voltage regulator has a problem and is overcharging the scooter. I don't have one of the regulators, but the voltage regulators found on the 250 cc scooters and the 500s from I think 2006, about 2005 to around 2009, they had a failure mode where they would fail and overcharge the battery. Some of the symptoms, you would have the check engine light on, and that's the computer, the fuel injection computer. It's stating that the voltage is too high. Of course, you'll need the special factory tools to look to see what the error code is. But if I would have started a scooter and had a faulty regulator that was overcharging, I would have saw voltages that were over 14.6, especially when you rev the engine just a tiny bit. I've seen them go as high as 18 or 19 volts with a faulty regulator. And only in those year ranges they had a bad batch of voltage regulators. The voltage regulators that were used later never seemed to have a problem. And one way to tell, I think the faulty regulator is made by Ducati. The regulators that never seem to have problems are they're sourced out of a Japanese or Chinese company. I never see problems with those regulators. I'm going to show you a scooter that's undercharging next. Happens to be my own scooter. I'll give you a little backstory on this scooter. This is my kind of everyday commuter BV350. It's got some extra load, like I got some extra auxiliary lights on it. I let a friend borrow it to go down to Mexico, and he was in lots of stop-and-go traffic going through the border, and he said it stalled out and he wasn't able to easily get started. He had to push the scooter through the international border. So we kind of limped the scooter back. I charged up the battery. The one thing with the BV or the Beverly 350, along with many of the MP3 models, there's a built-in voltmeter on the dashboard, and you can cycle through the mode switch. And I knew right away it wasn't quite charging the way it should be. You know, the voltage would drop below that float voltage, which is the voltage that the battery sits at when it's just idle without the ignition on. And so I was going to show my steps of how I troubleshoot the issue. So you start the scooter, you see that the voltage rarely goes up above 13.5, 13.6. The scooter's staying at the lower voltage around 12. If you had a weak battery, it might be as low as 11 with the load of the headlight and the fuel injection system and everything else that's working while the scooter started. Pretty much the same test I just showed you on the battery. You'd see low voltage, and I'll show you the steps of where you would look to troubleshoot next. On the GTS 300, you want to gain access to your the three-phase stator connection. And on the 250s and 300s, it can be found underneath the seat bucket. And on some models, they have a plastic cover here. Sometimes they don't. It's held with a single fastener. And you can see that large white connector right there. One thing, sometimes they're pretty difficult to get out, so you could take this little screw off to pull the bracket away from the scooter. Is what I'm going to do is disconnect this connection here. One thing to look out for is some of the early ones, they had a brown colored connection, and I've found that they don't quite hold up to the current load as good as these white connectors that were found on 2010 and later. So you'll see melted connectors. And the only real solution to fix if you have a melted connector, obviously you're not going to get the power going to the voltage regulator to charge the battery. You can cut the wires and make a nice solid splice of the connection. Otherwise you'd be replacing the wiring harness. Those connectors again are found on the like 2005 through 2009, along with that faulty voltage regulator. So I have this connector disconnected. This side, I guess this would be the female end. The other side has the connections on it. That goes to the voltage regulator. And I'll talk about where the voltage regulator is a little bit later. You want to set your voltmeter to alternating current. And what we're going to do is go ahead and start the scooter. You can start the scooter without that connector. Obviously it's not charging the battery when it's running. I'll see if I can do this. Actually, I'll just hold it right here. So between each of these connections with the alternating about 20 volts at idle, and you want to go between each one of these connections. So you can see that's normal. So each of those connections you should see anywhere from, I'd say 18 to 25 volts at idle. It goes much higher when you rev it up, but that's pretty normal right there. And the next test you want to do is you want to set your meter to the ohms position. And you can ohm between the each of the phases of the stator here. And I would say they're usually a half ohm to about an ohm, depending on how good your meter is there. But they're all measuring normal. So just in between each of the connections. And the last test you want to do, say it passes that test, is go between any of the 3 connections to ground. You know, the screw on this throttle body's ground, or you can go to the engine, and it should show overload, which is you know, there's high resistance, and that's normal. If it showed any sort of measurement, that means there's some leakage in the wiring internal of the stator plate. So everything reads normal on this charging system here. I'm going to go to a charging system on my own scooter that has an issue and show you what I find over here. So on my BV350, the identical connector, it's found underneath this cover. I kind of went ahead and pulled the screws. Obviously a little bit more difficult to work on compared to the Vespa. I mean, that's one of the beauties of the Vespa. They're definitely a simpler scooter to work on. Gain access to connections or hoses or whatever you need to do. Have it on the ohms position. I'm going to go between each of the phases. That looks about normal. 0.5. 0.5, and then I'm going to go to a ground. And it passes just fine. Next, we're going to go to AC volts. And I'm going to go ahead and start the scooter. Uh, 15 volts, a little low. 1.8 volts, there's something going on there. So I suspect inside the stator plate it's internally shorted. So we got 17 volts there, but this, between these two, 1.9 volts. That's too low. So that immediately rules out that there's some issue with the stator plate. There's one last test you could do where you could short all these together and measure the current that goes through the coils. Doesn't really tell you much more than the open circuit AC voltage test I just did. But pretty much come to a conclusion, I'm going to need to order a new stator plate for this scooter. One other thing, say the scooter's under charging. Sometimes voltage regulators also fail in a state where they don't generate enough power, they don't regulate correctly, or they lose some of the diodes inside the voltage regulator that converts the alternating current to direct current. Say if you saw 20 volts between each of those 3 connections in any order, I would check your wiring and then come to a conclusion, replace the voltage regulator. It's always important to check your wiring. If you have a melted connection or any loose connections, that's going to be your issue before the voltage regulator. I see a lot of people order voltage regulators through our shop. I don't know if they're ordering them for that range of GTS and BV 500s, MP3 500s that had the not so good batch of voltage regulators, or if they're just shooting from the hip and putting voltage regulators. Also get your battery tested. If your voltage regulator is overcharging, you probably already fried the battery, along with, there's a chance you might have blown some of your bulbs as well. I'll do a video next on how to change out the stator, essentially doing a water pump job on any of these 250, 300, 350, 500. The alternator is located in the oil bath, and it's underneath the right-hand cover that also houses the water pump. So I'm going to go ahead and order a new stator plate for my scooter, replace the water pump seal as well, along with the gasket. That will be next video. My scooter's got like 26,000 miles. Just first time I've seen a BV350 stator fail, and we have a lot of customers that have quite high mileages on their BV350s. So I'm not sure why mine's failed prematurely. Hope that helps everybody out. Until next time, this is Robot here, Vespa Motorsport, scooterwest.com. Follow us on Instagram, Vespa Motorsport. Follow me, Robot Vespa.